In this video series, we are going deeper. We will build a ChatGPT like model from scratch using the transformer architecture. Step by step, line by line, no magic, just code and clarity. So hit subscribe, smash that like button, and let's unlock the black box of LLMs together. Welcome to the world of large language models or LLMs. LLMs are deep neural networks trained on mind blowingly large datasets. We are talking tens, even hundreds, or billions of parameters. And here's the crazy part, they are trained on very simple tasks. Predict the next word. That's it. No magic spell, no secret formula, just one word at a time. Yet somehow this simple task teaches the model grammar, context, reasoning, even sarcasm. It learns to understand how we speak. What's the secret sauce? The transformer. Transformers help the model pay attention to the right parts of the input, just like how you focus on the keywords in a sentence. This attention mechanism makes them exceptional at handling the subtleties of language. That's why LLMs power tools like ChatGPT. They don't just complete sentences, they generate content, answer questions, and even write poetry. That's why we call them generative AI or Gen AI for short. Zooming out for a second, LLMs are part of the AI universe. AI is the big picture, machines doing smart stuff. Inside AI, we have machine learning where models learn from data. Go even deeper, and you get deep learning neural networks that learn complex patterns with minimal human help. Take spam filtering for example. Traditional machine learning, you would hand code features like free money, too many exclamation marks, suspicious links. But with deep learning, the model figures this out on its own. You just feed it enough labeled data spam or not spam and it learns the patterns. And that's why LLMs are such a big deal. They learn without needing you to tell them what matters. They can write, reason, and adapt across languages, domains, all thanks to deep learning and massive training data. You might be thinking, why build your own LLM? Sure, tools like ChatGPT are amazing, but what if you are working in finance, medicine, or law? That's where custom built LLMs shine. They are trained for a specific domain and they can outperform general models in their niche. Just like Bloomberg GPT, who made for financial data, you can create your own LLM for exactly what you need. And let's talk about privacy. Companies don't always want to send sensitive data to cloud based AIs. Custom LLMs let you keep everything local on your own servers or even devices like smartphones. That means faster responses, fewer cloud cost, and total control. What's the magic behind ChatGPT, BERT, or other language models? It's all started in 2017 with one legendary paper. Attention is all you need. This paper introduced the transformer architecture. And if you want to understand large language model, this is where you begin. The transformer was originally built for translating text like turning English into German or French. It works in two parts. Encoder takes the input sentence and converts it into context rich vectors. Decoder turns those vectors into meaningful output like translated sentence. But here's the real innovation, self attention. This mechanism helps the model figure out which words matter in a sentence, even if they are far apart. This is how it understands that bank in one sentence means money and in another it means river. Next came the heavy hitters, BERT and GPT. BERT uses the encoder only and is trained to guess masked words in a sentence. That's perfect for classification tasks like detecting spam or predicting sentiment. GPT, on the other hand, it's all about generation. It uses just the decoder and learns to complete sentences. That makes it great for tasks like writing fiction, summarizing documents, writing code, and translating languages. So, if you ever wondered how these models think, now you know it's all about attention and the architecture that made it possible. To build a model like GPT-3, researchers feed it hundreds of billions of words from website, books, code, conversation, you name it. This collection of words is broken down into smaller pieces called tokens. Think of them like a building blocks of language for AI. And get this, the cost to train GPT-3 roughly $4.6 million dollars in cloud computing. But here's the magic. Once trained, these models became foundation models. They understand language structure, meaning, and even general word knowledge. And you can fine tune them on your specific task like translating medical text or summarizing legal documents. No need to retrain everything. Just give them a smaller targeted dataset. Now you might be thinking, isn't pre-training only for big tech companies? Not anymore. I will show you how to code your own pre-training loop for educational purposes, and yes, you can run it on consumer hardware. So the next time you hear someone say AI just knows stuff, you will know it's because it was trained on everything. Let's talk about GPT, the model that redefined what AI could do. GPT was first introduced by OpenAI in a paper titled Improving Language Understanding by Generative Pre-training. Then came GPT-3A, beast with 175 billion parameters and 96 layers, all based on one simple idea. Guess the next word. This task is called self-supervised learning. No human labeling required, just predict the next word using the previous ones as context. Sounds basic, right? But here's the twist. From this one simple task, GPT models emerge with powerful skills: text completion, spelling correction, translation, and classification, all without being explicitly trained on those tasks. This is called emergent behavior when skills naturally arise from models' exposure to huge and diverse datasets. Unlike the original transformer, which had an encoder and decoder, GPT is built using only decoder. It's an autoregressive model, meaning it generates one word at a time, each new word depending on the words before it. That's why it feels so coherent when GPT talks back to you. While GPT's structure is technically simpler, it's way larger than the original transformer. And even newer models like Meta's Llama still follow the same core principles with only minor upgrades. What's wild is that GPT was not trained to translate, but because it saw enough multilingual data, it learned the patterns on its own. That's the power of scale. One model, endless task. This is your moment to go from theory to creation, to stop asking how AI works and start building it yourself. So grab your laptop, follow along, and let's code the magic of GPT one stage at a time. Subscribe now and don't miss part 2.